So hello everyone. In this video, we are going to look at another problem which has a very splendid application of bit manipulation techniques. And the name of problem is find a unique element. The name of problem is find a unique element. So before diving into the coding part, let's just go through the problem description and logic behind the problem. So find unique element. Find unique element. So it's quite simple. So what could be it? Hmm, Actually, we are given an array, okay, and in this array, all the elements are repeated twice. Okay, all the elements are repeated twice, but only one element is there which is present single, and rest all of them are repeated twice. So it could be something like 1 2 1 3 2 4 5 4 5, something like this. So here number 1 is repeated twice, number 2 is repeated twice, number 4 is repeated twice, and number 5 is repeated twice. Only this number particular here is present single, and we need to find this number. So what's the brute force approach? So I need you to type and code this solution on your own. Brute force approach is using two nested loops, for inside for, two nested loops, and doing this you can actually easily find if a number is present twice or not. Second approach is a little bit optimized, like approach 2, which is basically using a hash map. Use a hash map to store the count of each number along with the element. Okay, but till now we haven't discussed the hash map, so we are not going to look at this particular solution. For this, time complexity is order of n square. For this, and space is order of 1. For this, time complexity is order of n, and space complexity is also order of n. Now comes the interesting part. Can we design an approach 3? Can we design an approach 3 in which time complexity would be order of n and space complexity would be order of 1? Probably the most optimized approach. So yes, we can do this, and I want you for now to pause the video and look for the rules which we have discussed in our previous videos and which rule you could apply to solve this particular problem. So we can actually use the property of XOR, the property in which any number XOR with itself gives output 0. So if the numbers are 1 2 1 3 2 4 5 4 5, 1 2 1 3 2 4 5 4 5, and we basically XOR all the elements of the array. So 1 XOR with 2 XOR with 1 XOR with 3 XOR with 2 XOR with 4 XOR with 5 XOR with 4 XOR with 5 once again. So basically, one XOR with 1 gets cancelled because 1 XOR with 1 is 0. Then similarly, 2 XOR with 2 gets cancelled because 2 XOR 2 would become 0. Similarly, 4 XOR with 4 cancels out and 5 XOR with 5 cancels out. So at the end remains 3 XOR 0, which is nothing but 3. So, or you know, just I wanted to say that at the end it's just 3 which remains, and this is the answer. Perfect. So yeah, forget that 3 XOR 0, that was incorrect. So all I wanted to tell you that at the end what remains is 3 and 3 is the answer. So in a single for loop we can just XOR every element, keep on XORing every element. The similar ones would get cancel out, and the only remaining unique one will will be there, and that's the answer we will return. Perfect. So because now we know the logic behind this, let's just try to code this. But then before I start coding, it's a humble request, you pause the video and you try to code on your own. So give an array for 1 2 1 3 4 2 5 4 5. Perfect, something like this. So if this is the given array, and we need to find the unique element. S out unique element is, and then find unique, and we will pass our array as a parameter to this, and then static int find unique, and we will give our array as the parameter for this. Now what? It's simple. So initially our answer is equal to 0, then int answer is equal to 0, and we will use for each loop directly. Int x is to arr, for x in arr, ans is equal to ans XOR x, something like this, and then at the end return answer. So the time complexity is order of n for this particular for loop, and we have not used any extra kind of space. That's why the answer is the space complexity is order of 1. So let's see if there are any errors. Okay, what does it states? Okay, find unique, unique, find unique. Perfect. Now what? Let's just try to run this. Okay, the unique element is 3. So as we already discussed the logic, so unique element is 3. So that's all as far as this video is concerned. I hope you have understood the logic. The coding part was also very simple. Um, so this is the most optimized approach as far as this problem is concerned. But yes, then there was that necessary rule that every element only occurs twice and there is one element that is single. If by mistake any number occurs thrice, then it would fail. So it is particularly only when all other elements are occurring even number of times, and then there is only one element which is occurring odd number of times, then only this XOR logic will work. So please don't get confused, it's quite simple. So please keep practicing, please keep making notes. Thank you for watching till end, and if you think I have made any significant contribution to your logic building, please do consider subscribing, and I will see you in the next one. Thank you.